everyone, welcome. This is Aurora with Supercharged Math, and today we are going to get started with our algebra class. So we are in an algebra series for fall, and it's an Algebra 1 course, and every 2 weeks, we're taking 2 weeks to go through one session, and so this is the second half of session number 3. So we're going to be working step by step. Now, if you missed the first part of this session number 3, can you still participate? Yes, absolutely. And so we're going to go step by step. We have session number 3 is a big one because we're dealing with something called rational numbers and inequalities. So the greater than, the less than sign, when that gets involved with an equation, what does that look like? So if this has been an area where you felt like, oh, this is not making sense, or algebra is just not my thing, I encourage you, stay with us and let's really get this handled. You're going to ask questions as we go through class so I can help you as we are working step by step. Now, there is a workbook that's going to go with what we cover in class, so I'm going to introduce the concepts. It'll be a little bit of a review from last time, and then we're going to expand on it as well. So if you're a quick learner, absolutely, most people are. Most people can get it. You know, I can explain something and you'll be like, oh yeah, I got that. So you'll be in good hands. Okay, so we're going to go step by step, and then I'm going to show you on the website where you can download the workbook so you can continue working on your projects. We have a lot of labs and a lot of activities for this area of algebra specifically. So I want to make sure you don't get lost and try to do too many of them. You just want to pick the ones that are appropriate to your level. Okay, so let's go step by step. Now, if you have your math journal out, you have it? Okay, so let me just make sure the live streams are all looking good. And I think we are, yes, we are looking great. Okay, and so at any time during class, if you have questions, you are simply going to send me an email or use the chat box below. If there's no chat box, that's where the email comes in. So it's aurora@superchargedscience.com, aurora@superchargedscience.com. Okay, so I'm going to take you down to my desk, and you are going to be, let's see, I just taught a fractions class, so we have a few notes still here. So you're going to be writing down whatever it is that I am writing down as well. And I do have a story for you. Thank you for asking. Don't let me forget. I have a story, and I also have a puzzle that we're going to talk about. Okay, so we have a topic called rational numbers. And this is a number that can be expressed as a fraction. Let me get down here a little bit. Okay, a number that can be expressed as a fraction. Rational number would be this. It would be that. Okay. It would not be something like, and repeating decimals are also rational numbers. So if this goes on forever like this, and it can be written as 1.3, we also call that a rational number, okay? Because that can be written as 1 and 1/3, okay? Or 4/3. Good. Okay. So rational numbers are not numbers, for example, if you have a decimal number that does not repeat and it keeps going on and on and on, that is not a rational number. If you have something, which we're going to get into soon, something else like this, when you take the square root of a negative number, that's not going to be a rational number. Okay, just so you're clear on what we're talking about. All right, so rational numbers. The thing we're really going to focus on today is something called inequalities. And an inequality simply means that we are using these things, okay? So it can be a greater than, a less than, or it can be greater than or equal to, or less than or equal to. That little line is less than or equal. Sometimes you'll see it with 2 lines under it, sometimes just with 1, but they mean the same thing. All right, so let's do a quick review. If I said the absolute value of x is greater than 3, what does that mean? Okay, what are these bars? Okay, it just means whatever's inside, just take the positive form of it. It means we don't care if the number is negative or positive. So if the absolute value of x is greater than 3, what does that mean? That means that you just rewrite it, but take the bars off. X is greater than 3. Okay, that's true. Right? So if I put x is 4, 4 is greater than 3, that's true. Right? So if I have a number line, okay, and here's my 0, 1, 2, 3. 1, 2, minus 3. Okay, x is greater than 3. So that means x can be, it's greater than, so it's not going to be 3. Right? Because if I put a 3 in here, 3 is not greater than 3. 3 is equal to 3. How about 4? Could I put a 4 in for x? Sure. Yeah, 4 is greater than 3. So x can be anything 3 onwards, but it can't be just 3. Okay, so it can be anything from 3 onwards. Okay. But there's something else. Because it has an absolute value bar, what we do is we write it without the bars, and then we write x is, and then we flip this, and we put a negative sign here. Because watch this. If I put 4 here, 4 is greater than 3, that's true. If I put a negative 4 here, negative 4, if we take the absolute value of negative 4, and we covered absolute values actually back in pre-algebra, so if I say negative 4, okay, is that greater than or less than or equal to 3? It is, right, because negative 4 simply means, the absolute value of negative 4 just means 4. So we just take when we take the bars off, we take the negative sign with it. So it just means 4. And 4 is greater than 3. So yeah, this would be true. So negative 4 works too. How about negative 5? What if x is negative 5? Is that going to be greater than 3? Yes, because negative 5, when you take the bars off, it just becomes 5. 5 is greater than 3. Okay, so what does that mean? That means that x can be a number that is less than negative 3. Why less than? Because it's going to go, oh, I should have drawn my number line longer. There we go. It's going to be a number that can be negative 4, negative 5. Remember, when you go this way, the numbers get bigger, but their value gets less. Okay? So the answer to this is x is greater than 3 and x is less than or negative 3. You got to stay away from the middle, because if you put 0 in here, 0 is not less than 3. If you put a minus 1, that'll turn into 1 is less than 3. 1 is greater than 3, and that's not true. So you kind of see how that goes. So this is stuff we covered last time. So if this is a little fuzzy, make sure you do go back and spend a little bit more time understanding what it is we're doing here. And just simply, we're rewriting this without the bars. X is greater than 3, and that's this part. And then we're flipping this and then putting a negative sign, and x is less than negative 3. And we're saying, okay, it's also this part. Because of the absolute value, because of these bars, we have to do this part. If there were no bars, we would just stop at the top. But because we have absolute value bars, we have to take into account there are 2 possibilities for an answer. I know, confusing, right? Okay, so let's go slow. I have some examples, and I want to get a new pen. My pen is running out of ink. Okay, so let's do it where it's not just x in the bars, but it's x plus 1. Okay, it's greater than 2. Okay, so what is that? Okay, so we're going to write it first without the bars. Just take the bars off, write the thing down. X plus 1 is greater than 2. Okay, just write it down. All right, and, okay, this is where it gets a little funny, so watch me. X plus 1, so write this down again, and then flip the sign and make it negative. So that means if it was negative, well, it depends on where the sign is. If it was negative, it becomes positive. So you flip the sign. Okay. All right, so what do we do with that? Now we have 2 equations to solve. So let's solve this one. I'm going to put the 1 on the other side, so minus 1, minus 1. X is greater than 1. That's this solution. This is minus 1, x, and then the less than, minus 3. All right, somebody's asking, when do we flip the sign? We flip it when we take the bars off. And then if you're asking over here if there are no bars, when do you flip it? It's not for addition and subtraction. Remember, we only flip the inequality for multiplication and division by a negative number. Okay? And since this is not, we're not multiplying or dividing, we are adding and subtracting, we don't flip it. Okay? So I'll do an example where we do flip it so you can see. Okay? Yeah. The hardest part about these is knowing when to flip this thing. Okay. So on a number line, what does this look like? Okay? So we have our 0, 1, 2, 3, 1, 2, 3. Here's our 0, 1, 2, 3, minus 1, minus 2, minus 3. Here, I'll keep going. This will be minus 4, minus 5. Okay. So what does this mean? X is greater than 1. Because there's not a little equal sign, we have to circle. We find the number, and we put a circle there. And then we say it's bigger than 1. So the numbers go this way. Okay, so X can be any of these numbers. So we don't, it's not like having an equal sign where I say x is equal to 1. Then I would just be coloring in that and be no arrows anywhere. Okay. But because it has an inequality, it could be a range of numbers, right? You get a speeding ticket if you go 56 miles an hour and higher. But at 55 and below, no speeding ticket. What's my speed? Well, it could be anything in here and it'd be okay. All right, so x is less than or equal to minus 3. So find the minus 3 first. Put an open circle because there's no bar under this. Okay, and then x is less than minus 3. So that means it's smaller. It goes away from 0. Okay, so this is the range. So x can be here and here, but x cannot be from 1 to minus 3. You cannot have any values of x. It'll break the statements. It won't work. So that doesn't work. Good. So my solution might be x is 4, and that would work because that's greater than 1. Or x is minus 10, and that would work. Yeah. So I have a bunch of numbers that will make this statement up here true. Here, let me back this up just a little bit so you can see the whole thing. Good. All right, how's that feeling so far? Good? Okay, so let's do a few more. Let's do a few more, okay? All right, and if you missed any sessions, some people are saying I missed last week. It's okay. The recordings are always up. You can watch them anytime, so take your time. All right, so x minus 2 is less than or equal to 10. All right, so because there are bars, these are absolute value bars, what we do is we write the thing down without, we just take the bars off and we just write it. See? Same thing, no bars. Because there are bars, there's another set of solutions that are possible. So what we do is we write this side, and then when we get to, so we wrote this, right? And then when we get here, you flip it, and you can't flip an equal sign, so it stays there. And then we put a negative 10. Okay, do you see how we do that? All right, and now we just solve each of them. We solve each of them. So I'm going to say plus 2. So x and plus 2 and minus 2 go away. So just carry this down. Okay, so it's exactly the same. 10 plus 2 is 12. So there's one solution. This is plus 2, x, and you're just going to bring down the inequality sign, minus 8. Okay, so these are both valid solutions. Both valid solutions. Okay, so on a number line, what does that look like? What does that look like? You want me to do another just plain absolute value so you can understand what absolute value is. Okay, I can do that. All right, so there's the 0. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Say that one's 12. Okay. All right, there we go. So what does this mean? This means that I go over here and then I find the 12. Because it's an equal sign, I circle it and I fill it in. That means x can be equal to 12. That's allowed. That's allowed. Okay, and then this one, oh wait, let me finish. It says it's smaller, so it's going to go this way. This one says minus 8, which is here, and this one is also equal, so I fill it in. And it says it's larger than minus 8, so it goes towards the 0. So when you have them pointing at each other like this, we just fill it in. You can just fill it in and just draw right over your arrowhead. There you go. So the solution to the numbers that will make this statement true are between negative 8 and 12 and including negative 8 and 12. So any of these values will be true. You could put in an x is 0, x is 0.2, x is 3.4. That will work. So any of these values will make this statement true. Do you want to see how it makes the statement true? Okay, so it makes the statement true because let's pick x is equal to 0. How about that one right there? That's an easy one. So if x is equal to 0, that means wherever you see an x, you're going to put a 0. So 0 minus 2 is less than or equal to 10. Okay, so what does that mean? 0 minus 2 is minus 2, and it's got bars on it, less than or equal to 10. So that's what we want to know. Is it less than or equal to 10? Okay. So the absolute value of minus 2 is 2. Is 2 less than or equal to 10? If you had 2 cookies, do you have less than my 10? Yes, this is true. So 0 is a valid solution for x. Valid solution. Good, because that does equal 10. or I'm sorry, it is less than 10. Good. Okay. So somebody's asking definition of absolute value. Okay, so just real quick, absolute value, all it means is that I have a number line here. Here's 0, 1, 2. Okay. I'm saying that, say I'm right here. What value is that? That's a 1. Okay, if I didn't make that very even, did I? Is that going to bother you? Here, I can fix it. We want them equally spaced. Here, -1. Okay, and you see this is here? This is a value of -1. Okay. So I want to know what is the absolute value of this. It just means how far is it from 0? It is a value of 1 unit. What's the absolute value of this, of -2? It is 2 hops from 0. That's what I want to know. So absolute value is just saying what, you just get rid of the negative sign. So absolute value of -13, I want to know how far is -13 from the 0. Well, it's 13 hops, and that's what I want. So the absolute value just means take the negative sign off. That's all it means. It means I don't care about plus or minus. The trouble is if you do this, it also means there are more than one solution. So if I said x is, let's say, less than 2. Okay, so what are the values that make this true for x? What if x is 2? Would that be true? No, because now you're saying if x is 2, now you're saying 2 is less than 2, and that's not true. Not true. True is not 2 is not less than 2. It's equal to 2. Okay, so x can't be 2. Okay, so let me grab another piece of paper here. So if I said absolute value of x is less than 2, what that means is there are 2 possible solutions. There's x is less than 2, so you just write it without the bars. And then you also say x is greater than -2. And it's this one, I think, that where the confusion comes in, right? Okay, so what this is saying is, well, here, just try it. If I put in x is equal to 0, would that work? 0 is less than 2. Yes, that would work. What if x is 1? I have 1 is less than 2. Yes, that would work. How about x is equal to -1? Okay, this is where the tricky part comes in. So -1, what's the absolute value of -1? Absolute value of -1, this is a 1, is 1. Is 1 less than 2? Yeah, so this one works too. So because it's an absolute value, we have to account for that flipping over the 0, and that's where this comes in. You have to flip the sign and add the negative sign, because watch what happens on the number line. Okay, if we just look at this one, x is less than 2. Let me put some points in here. 0, 1, 2, 1, 2. Okay. So x is less than 2. Here's 2. And we say, well, it can be anything less than that, right? That'll work. Okay, but what if I put in x is equal to -4? Okay, that's less than 2, right? X is less than -4, so that means the absolute value of -4 is less than 2, right? Uh-oh, look what happened. The -4 becomes a 4 is less than 2. When we take it out of the absolute value bars, that's not true. So we have to account for that. And that happens because of the absolute value bars. So that means that I find this here, -2, which is 1, 2 here. Okay, and it has to be bigger, so it goes towards the 0. So my answer is bounded between -2 and +2. So x can only be in this range. It can't be anything larger, because any other larger number, when you take the negative sign off, anything larger than 2, it becomes bigger than 2, right? Or yeah, so that wouldn't work. Are you kind of seeing that? So the best way to get used to these problems is just to work on them, just to do a bunch of them. So let's do some more examples, yeah? Okay, you can let me know in the chat if this is helping, doing a little extra example explanation. Okay, let me actually flip to a larger piece of paper so we can get more in the camera. Okay, so I have 3x minus 2 is equal to 7. Ooh, do you see that? Equal. Okay, what does this mean? This means I'm going to write it down. 3x minus 2 equals 7. And, hang on, there's more. 3x minus 2 equals negative 7. You can't flip an equal sign around, right? They're the same thing. Okay. Why did I put the minus sign there? Because look, the absolute value of this thing equals a number. But if I get negative 7 in here and I have absolute value bars, it's going to turn it into a positive 7. So either positive 7 will work. That's this. This equals positive 7. And this thing equals negative 7. That'll work because I'm taking the absolute value. And this is where you go, oh. All right, so let's solve for x. Okay, so plus 2. I have a 3x, this goes away, equals 7 plus 2 is 9. Divide both sides by the number whatever's in front of the x. And then I will have x is equal to 9 over 3 is 3. Good. All right, let's go over here. I'll do this one in red. Okay, so I'm going to have a plus 2, 3x, this goes away, minus 7 plus 2, that's equal to a minus 5, right? Because 7's the more negative number. Divide both by 3, because that's whatever's in front of the x. X is equal to minus 5 over 3. Doesn't that seem like a funny answer? So both of these will work. And let's test it. Let's test it. So if we put a 3 in here, 3 times 3, well here, where'd my paper go? I threw it on the floor. Okay, so let's test it. Okay, so if x is equal to 3, that means the absolute value of 3 times 3 minus 2, does that equal 7? Let's see. This is a 9 minus 2, and we're taking the absolute value of it. 9 minus 2 is positive 7. Does that equal 7? Yes, it does. Yay! Okay, so x equals 3. We like that. It works. It gives us a positive 7. Take the absolute value. It's still 7. Good. What about the other one? What about the minus 5 over 3? Okay, so let's check that out. So if x is equal to minus 5 over 3, I'm going to have 3 times minus 5 over 3 minus 2. Take absolute value. Okay, I want to know what that equals. I hope it equals 7. Okay, so 3 on top, 3 on the bottom, those go away. Otherwise, you get 3 times 5 is 15 divided by 3. So this is a minus 5 minus 2 inside absolute value bars. Are you seeing this now? Look, this is minus 5 minus 2. You get a minus 7. Take the absolute value. That negative goes away. It equals 7. And that works. Yay! Right? Yeah, so I have found that doing inequality problems gets easier the more you do them, because that's the more distinctions you're going to be making. Because there will be something that I'll say, something that I'll write down, or something that you write down, and you'll be like, oh, I get it. Oh, that makes sense. So sometimes it could be just plugging it back in like we just did. Okay, what happens if this is the case, where the absolute value is here? Right? It's not x plus 9 absolute value, right? What do you do now? Okay, you solve it just like you normally would. Okay, this is the absolute value equals, this goes away, 12 minus 9 is 3. What does this mean? What values of x make this statement true? X is equal to 3 and x is equal to minus 3. Because if I put a 3 in here, 3 equals 3. That's easy. But if I put a minus 3, put the minus 3 in the absolute value. Absolute value of minus 3 is 3. So this works too. So we have 2 solutions. Now, in real life, what happens is you'll do problems like this. You'll get 2 or more solutions, and then you have to bring it back to the real world and realize there's no such thing. You can have negative 3 candy bars. So you can cross one out because it doesn't exist in nature. Or maybe you can't have a positive number for something, right? Maybe the temperature can either be positive 3 or minus 3. And it's got to be below 0 because you're dealing with ice cubes, so you can throw that one out. So you start to eliminate which one. You can't have, sometimes you can't have 2 or more. Like the math will give you answers, but not all of them will make sense in the real world. So right now at this point, we're just taking all the answers that we can get. And then we'll learn how to interpret things to figure that out. Okay, somebody's asking, what if your absolute value is multiplied by a number? Okay, what about something like this? Okay, so when you write it like this, make sure that if you're writing the number 1, anytime absolute values are in my problem, my 1s, which normally look like this for like 18, I will write them as this, so it's really clear this is not 21x, right? So make sure it's really clear that if you write the absolute value bars, it's got to go above and below so you don't make mistakes. Yeah, I know. Anybody made mistakes in math? Yeah, we all have. Okay, so you deal with it the same way. So what we're going to do is I'm going to get rid of the 2 first. Okay. And this may look a little weird, but it works. Okay, so this goes to 8 divided by 2 goes to 4. So now I have absolute value is equal to 4. So you tell me what are the values of x? What does x have to be to make this statement true? Yeah, positive 4, and what else? That's right, negative 4. If you want, you can also write it like this. X is equal to plus or minus 4. Okay, that means the same thing. Same thing. Okay, I have a couple of more problems. I have 1, 2, 3, and then we're going to talk about a math machine. We're going to talk about a math machine. Okay, and I do have a story for you. Yes. Okay, good. Okay, it's helping. Good. Can you give us a bunch of questions? Yes. When would you use this in the real world? Remember the speeding ticket? That's an easy one to think about. When do your parents get a speeding ticket? Well, when they go above a certain speed, right? How about 96 miles an hour? Yeah. How about 97? Sure. How about 95? How about 88? How about 76? Do you see how there's more than one solution? It isn't just a specific discrete number, it's a range. Anything above the posted speed limit, say the speed limit's 55, 55 and below, here let me write it down as a thing. So this actually gets used all the time. If you want, I'll tell you my fighter plane story. X is less than or equal to 55. Say this is the posted speed limit, right? Speed limit, or maximum, I think it says, yeah? MPH, right? So this is on the side of the road. So this means no ticket. This means, oh, wait. Did I write absolute value bars on there? I did. Look at me. Okay, hang on. Can I do some paper magic? There we go. There we go. Sorry, you don't need absolute value bars. This is just inequality. So if your speed, x, is less than or equal to 55, you won't get a speed ticket. If it's greater than 55, then look out, right? Because if there's a cop behind you, how many people go below the posted speed limit when there's a cop on your tail? Everybody, right? Especially if you're looking. So the ticket range is open circle this way, right? So this is 56, 57, right? Miles per hour. And closed this way. This is the no ticket. No ticket. Okay, red is ticket. And actually, scientists use this more than they will use discrete answers. So when they do their science experiments, they will get a range of things that are possible that are okay to use. And then, and so we don't, it's half, I want to say it's like half and half. It depends on the field that you're in. And so when I was working on some new engines, they were not performing. And I had to give them a performance envelope to operate that, those engines in, because otherwise, if they operated outside that envelope, the airplane wouldn't fly. But they could do a bunch of stuff within this envelope, performance envelope. And so it was a more complex example. So yeah. All right, shall we continue? All right, let's do a few more examples because inequalities, it's one of those things where if you ask a regular math teacher, they'll look at you and say, I don't know, but you need to learn it. I will give you an exact, well, there's a lot of labs that will show you how to use this stuff too. So let's get good at the calculations. So by the time you get to the lab part, it'll be easy. Okay. All right, ready? What do we do first? Okay, so there's a negative sign there. And there's a 5 here. Can I multiply negative 4 times 5? No, it doesn't work that way. What I do is I want to get rid of anything in front of this. So I'm going to go minus 4, even though there's a 5 there. Leave it alone. All right, so -4 over -4 goes to 1. I have absolute value of 5x is equal to, negative sign, there's only 1, so it stays. 12 divided by 4 is 3. Okay. All right, now I want to take the bars off. So you're going to write it first as it looks with no bars. And then you're going to write it again. Okay, and then what do I put over here? Yeah, you can't flip an equal sign, right? And then, so you put that down, and then the opposite of -3 is +3. Good. So what are my solutions? My solutions are going to be divided by 5. X is equal to -3 fifths. Divided by 5. X is equal to +3 fifths. All right. How does that look? Good? All right. So what did we do? We got rid of anything outside of the bars. Took care of that first, did it to both sides of the equation, okay, just like we're getting used to doing with algebra. Then you deal with the bars. When you take the bars off, that's when you just write it as it is, and then you've also got to take into account, what if this is a negative quantity inside, and then we make it positive, right? All right, are you seeing a problem? Does anybody see a problem here? Tell me you see a problem. Oh, please tell me. Please, please, please tell me you see a problem. Will you get actually any solutions for this thing? Look, you have the absolute value equals a negative number. Look at that. Is that even possible? No. This is what we call a bad problem, because you can plug and chug along, and look, it sure looks like I can. I can do the calculations. You've got to think about what you're doing. This is not possible. Well, it's not possible with where we are. So you would just say, no solution. And the thing that should have tipped us off is you can't change a negative into a positive right there. Okay. So I want to do this one in case this pops up for you. Okay. And if this happens, usually what happens is if you're doing a math problem from a math book, it means you messed up on your sign somewhere. All right, can we change this so it is a possible solution? Yes, absolutely. That's a good question. Here, let's do it now. All right, so what if I change this so it's -12? What do you think about that? Would that solve it? Okay, so let's try it. So I'm going to divide by -4, divide by -4. Okay, and what do I get? I get a 5x is equal to, 2 negatives make a positive, 12 divided by 4 is 3. 12 divided by, you want to see the bad problem first? Okay, here. You want to see the rest of the bad problem? You can't have an absolute value equal a negative number, right? So I wanted to do this so you would see, like, it seemed like it was logical, right? Happens to all of us. Yep. Okay. So let's fix the problem so it works out nice. Okay, so we don't have any problems like this. All right, so what do we have? We have a 5x equals 3 and 5x equals -3. You should always have a minus on this other one. Okay, so that's a good check. You're going to remember now, right? Good. Okay, so we're going to divide by 5, and what do I get here? X is equal to 3 fifths. And divide by 5, divide by 5, x is equal to -3 fifths. You're like, wait, you got the same answer, but the problem's different. I changed the problem, didn't I? Yes, I did. So you can also write this as x is equal to plus and minus 3 over 5. All right, I'm going to leave this here, so you can write it as 3 over 5 if you want. Okay. All right, so how are you feeling about this so far? Good? Excellent. Good, good, good. All right, so I'll leave that up just for a second. I have one more I want to do, and then we're going to talk about a math machine. Yeah. Okay, and then you ready for me to take it off? Okay. All right. You like the example where I do the wrong thing. Okay. You don't like the example. All right, so I will tell you when things are not right. So I did that on purpose so you would know. Okay, so let's do this one. Let's say I've got a minus 4, and this is a 5x is less than or equal to 12. Okay, so we have a lot going on with this problem, right? Got a lot going on with this problem. Okay, so the first thing we're going to do is we are going to divide by a negative number. Okay, by a negative number. Anytime we divide by a negative number and it's an inequality, you're going to have to flip that. Okay, so minus 4 over minus 4, that goes away. So we have the absolute value bars around 5x. Flip this. Here. F-L-I-P. Flip. Okay. And this is a minus, and this is a 12 over 4, which is a 3. Okay, so can 5x be greater than or equal to negative 3? Sure. Yeah, the absolute value can be greater than or equal to negative 3. Yep. So what does that mean? That means we have, let's take the bars off. We have a 5x is greater than or equal to negative 3. You just rewrite it. And we also have a 5x is less than or equal to, and then what do we have here? Positive 3. Okay, and so I'm going to have a solution here. Divide by 5. I have an x is greater than or equal to minus 3/5. And divide by 5, divide by 5. X is less than or equal to 3/5. Okay, and we'll do a number line so you can see. All right, so for this one, okay, so here's 0, minus 1, and 1. Okay, and so we're going to find 3/5, which is, let's say it's about here, and negative 3/5, which is there. Because it's equal to, I'm going to color it in. Okay, so this is positive 3 over 5. This is negative 3 over 5. Do the arrows go that way, or do they come towards each other? Which way? Well, it says this is smaller than 3/5, so I'm going to start heading this way. This one says it's larger than negative, so if it's larger, it goes towards the 0. So for this statement to be true, you can pick anything between negative 3/5 and positive 3/5, and that will make this statement true. Yay! Awesome! How are you feeling about this so far? What happens if there's a denominator in the absolute value? That's a good question. That is a really good question. Okay, you want me to leave this up just for a second? Okay, I'll leave that up just for a second. Go ahead and copy it down. Okay. All right, so are you ready? Let's go ahead and take a look at, let me make up a problem here. How about x divided by 3 is less than 2? All right, so there's one where we have absolute value bars and a denominator. How's that? Does that look good? Okay, so first thing, what do you think we do first? Yes, we just write it without the absolute value bars, right? So we'll say x over 3 is less than 2. And then what do we write? X over 3, and then what do we do? Is greater than 2. Okay, and then we just solve it. So we're going to multiply both sides by 3. This goes away. X is less than 2 times 3 is 6. There's one solution. And I'm going to multiply both sides by 3. That goes away. X is greater than 6. All right, and then if we have a number line, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, I made a mistake. Did you catch it? I caught it while I was doing the number line. Where's my mistake? Did you see it? Yeah, so when I flipped the sign, I forgot the minus sign. So that means this is minus 6. Okay, so I'm going to find the 6 on here. So 1, 2, 3, 4, 5. So this is my 6, and it's going to be smaller than 6. And I'm going to find my negative 6, and it's going to be bigger, so it's going to head this way. All right, and that is as far as we're going to go. If this is starting to make a little bit of sense, then absolutely you're doing fantastic. If this is still like another language, that's what the workbook is going to be for. So I'm going to introduce one more quick idea that actually it's not new. You already know this. So we're going to talk about that really quick. And then I'm going to show you where in the workbook you can start working on and which workbook it is, where to find it, all the labs, projects, challenge activities, projects, all of the fun stuff as well. And then we will continue. All right, so let me just show you one more thing. How many of you anybody like to build things? Do you guys like to build? What sorts of things do you like to build? Do you like to work with? Do you like to work with maybe wood? Or in my day, it was called an erector set. Maybe Legos, if you like to build things with Legos. Okay, so if you can imagine a machine, and think about maybe like a vending machine, right? And so if I put a quarter in, I know nothing is available for quarter anymore, but just imagine, right? If I put a quarter in, and I can expect to get maybe a quarter out, right? I wouldn't put a quarter in and expect to get other things, right? Okay, so we're going to build a machine where we're going to put something in and something's going to come out. All right, so build your machine with me. Get a new piece of paper, and here we go. So this is a math machine, and they are called functions. Functions, what they do is they relate an input. Here, just write this down with me. The input is going to be called x to an output. And we call that f of x. Okay, so watch this. So here's our machine. So I'm going to say my input is x. Okay, my input is going to be x, and f of x is going to be 2 times x. So that means if I put in an x of 0, over here for x I'm going to put 0. What is 2 times 0? Yeah, it's 0. If I put in a 1, if I put a 1 in for x, what do I get? 2 times 1 will give me 2. What if I put in a 2? Okay, so I'll put a 2 over here. 2 times 2 is 4. You kind of seeing how this goes? All right, what if I put in a negative 1? Will it work? Or will it break our little machine? Okay, so if I put a negative 1, what happens? 2 times negative 1 is a minus 2. So what are we doing? So we have a machine, and I am putting in, you can think about our machine like this. Okay, so I have numbers here. This is our x numbers. Okay, so I put in a 0, it goes into the machine, and it spits out a 0. And I had a 1, we put it into the machine, and it spit out a 2. And I put a 2 into the machine, and it spit out a 4. See? So this is our numbers that we get back. Okay, each one of these inputs only has one possible output. Notice I can't put a 0 in and get a 0 and then also get a 2, right? No, there's one distinct number I can get out. Let me show you. So if I have, this is my x, and my function, f of x, just means function of x, that means x is in here, is x minus 1. Okay, so suppose I always start with 0. So if I put 0 minus 1, and that's going to be a negative 1. Okay, so I put a 0 there. So this is x minus 1, 0 minus 1. Okay, great. What if I put a 1 in? Okay, so where the x is, I'll put the 1, and then I just put minus 1, because that's what's here. 1 minus 1 is 0. Okay, what if I put a 2 in? All right, so 2 minus 1 is 1. What if I put, what number should I put in? You guys want to tell me when to put in? If I put in a 6, all right, a 6 minus 1 is 5. Okay, so are you seeing how when I put 1 in, I only get one answer. I don't get 2 answers out, right? That's just not the way this goes. Okay, so, oh, you guys are telling me to put in 10. Okay, I'll do one more. So 10. All right, so 10 minus 1 is 9. Okay, so all I want you to get is that, and even write this in your notes. So each input only has one possible output. Okay? And that's as far as we're going to go. So I just want you to see that every time you put an input, you get one output. So I'm not getting, I can't put a 1 in here and get like a 0 and a 4, right? I get 0. So based on this function up here, this is our little math machine. And when you insert your quarter that says 0, it spits out a -1 chocolate bar or something, right? Okay, so these are functions. And from now on, from now to the rest of algebra, we are going to be using functions too in class. All right, that was it for class. Yay! I know, we went a little long. Well, to be honest, it's because I answered a bunch of questions too during class. All right, so where do you find all of the goodies for this week? Okay, and for this session, I should say. Remember, it's 2 weeks for every session. All right, so first of all, there is a math assignments outline. You want to make sure you download that. Where you find it, I'm glad you asked, is right here on the program. You hover on Unit 4, Algebra, and just kind of hover down to session number 3, and then you'll get to this page. The video on the top is always the parent page. I don't know if you can see it, but right here it says Math Assignments Outline. Okay, and so you open that up, and this is the Math Assignments Outline that you'll be using. So the first thing you want to do is the workbook. Okay, so where do you find the workbook? You go back to the page. Over here on the top right is going to be the workbooks, and then you're going to open it up. So these are the workbooks for all of the entire program. So scroll down until you see the word algebra. Okay. Now algebra has a couple of different sets of workbooks. So the first set we've already completed. Those are pre-algebra. So if you're still in pre-algebra, then obviously you're not in this session right now. So that's set number 1. We are currently in set number 2. Okay, so set number 2. We are in, do you see where it says Algebra Workbook Rational Numbers? It's the second one here. And so you're going to download that. There are lots of pages to do. If you find it too easy, after you've worked through it, you're going to take the 2-page test at the back. If you can, it might be 3 pages, I forget once we get going. But if you look, the practice test, it has exactly what we were doing in class today. You see the functions are down here. We were doing absolute values. Yeah, so this is your practice. So this workbook, we covered all the content that is going to be covered in this, how many pages? 37-page workbook in here. Okay, so you're going to do that workbook, and you're going to take it step by step. And if you would like me to work through the workbook with you, there are instructional step-by-step videos. By now, you've probably found them. So you would go to the session you want, session number 3, that's where we are. Okay, and then do you see if you scroll down where it says beginner level math class, okay, and then download your algebra workbook, okay, and then I have, wait, where's download your workbook? Algebra, here it is, rational numbers, okay, and then this is, you just look for the workbook, rational numbers, and then I will walk step by step through the entire book with you, and it's really fun. We do a lot of the problems together, we have races, so you don't feel stuck or alone, and so, yeah, so we do that together. Good. All right, so remember, it's workbook set number 2, rational numbers, and you want to do as much of the workbook as you can, so remember, use it strategically. You're using it to get good practice at what we've been covering in class. And then when you're done with that, you're probably ready for some other type of math activities. So I have converting units for you this week. I also have lots of different solving things, like solving inequalities. There's task cards, games, scavenger hunts, coloring pages, cutouts, crossouts, lots of fun things. There's also a review so far of what we've been doing. So we are reviewing because there's a lot of content. Would you agree? Okay, so this is our 6th week in algebra, so it's time for a review. So finish all of the other things I had mentioned, like all of the other projects, activities in the math assignments outline. Finish that first. And then you can hop over to the review, and we will start to review everything from sessions 1 to 3 to make sure you're good to go. Because there's only 7 sessions in algebra. If we waited till the 7th session, it's going to be too much to review for the first time. So we're going to review, and then you're going to use that review in there. And then you can enjoy some scavenger hunts if you'd like to do that. If you're one of my more advanced students and algebra is this is already easy for you, you've done the review, you've tested out of all the workbooks, what you can do is start to work on the physics problems. So Remember how this program works is you go beginner, intermediate, beginner, intermediate, beginner, intermediate of all the sessions. And then you circle back around and do advanced, 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 because advanced assumes you already know most of the algebra concepts. And so what we're doing now is we are going to high school and college level practical applications, and you're going to see how we actually use algebra in the real world. Now, if you're a beginner but you want to know, absolutely, take a look at it. But just know that I don't expect you to keep up with the problems yet until you're at a more advanced level. But beginner and intermediate, you're welcome to take a look. These are fun problems. I mentioned these before. Where we're dealing, one of them is a chemistry problem, where you're trying to figure out what type of, you want a certain concentration of a certain chemical. In this case, it's a fish tank, but it could be anything. It could be hydrogen peroxide, it could be sodium chloride, it could be anything, right? You want a certain, well, that would be salt water. you want a certain concentration, but you've got these concentrations on the shelf. How much of each one makes what you really need? And so this is a calculation you're going to do in chemistry class all the time. There's another one where it's cliff diving. So based on, or you can even just throw rocks. And if you can be able to tell the speed that the rock is about to hit the water with, in addition to how high it flew off the cliff, like how high the cliff was, just based on timing information, because it was in free fall motion. So that's a physics problem that uses algebra. And so all these problems are in there that you can take a look at and work through. And so yeah, these are taken from college level classes, because by the time you're done with algebra, you move on to geometry and you forget most of your algebra. And then so they circle around to algebra 2 and they spend the first third of algebra 2 reviewing algebra 1. And then what they do is they kick you into calculus, like trigonometry calculus, and you don't use algebra a whole lot. We'll use a little bit, but not a lot. And then you get to physics, and then it's been like 6 years, and then they say, oh yeah, remember those algebra skills? We need those right now. So because there can be a really long stretch before you ever get to know what this math stuff is for, that's why we have the advanced labs in there, because we want you to see front and center, how do we use algebra? How is it, how do college kids, how do scientists, how do astronomers, how do chemists use this stuff? How do engineers use it in their everyday lives? So, and it happens in college too, because what do? For freshmen and sophomores, I taught mechanical engineering, so I know this. So what do? They make you take all your calculus classes, and then when you're junior and senior, they start giving you whatever the classes are for your concentration. For mechanicals, it'll be vibrations and thermo and fluids and controls, and they're going to say, oh yeah, and you're gonna work on your physics equations and so forth, and you'll work on that, and then they'll say, oh yeah, just do the math and figure it out. But they won't explain it because they'll assume you've already done it, but you did it a few years ago. So we want to start bridging that gap and getting you to see where algebra gets used, how it gets used, because algebra is a way of thinking. We are training your brain how to think about math problems and starting to get those pathways in your mind. So when you look at a physics problem, it's not just like, I have no idea how to think about this, but you're starting to learn how to do this. Think about like riding a bike. So you know how to ride a bike, right? If I said, could you take this package down to the mailbox for me and take your bike? Well, you may have never done that before, but you know how to ride your bike, and you can figure out how to tie the package on safely so it doesn't go flying. And then the two of those put together, now you've got a way and a method for doing this. And it isn't such a big deal, versus if I just introduce the package and the bike and say, can you do this for me? Oh, by the way, you'll be riding in traffic too. And like, right? So you need to get good at learning how to think, and math does that for you. Memorizing the multiplication table does that, one of those pieces for you. That's one of the reasons we use it. Algebra is a big part of this. If you get really good at algebra, chances are, if you're going to go into like a science and engineering field, you're going to have a lot easier time because you've already got that methodology in your head and how to actually think. That was a really long-winded explanation about why this stuff is so important. I hope you're getting this. Okay, so you've had a break. Are you ready for a math challenge? Come on, say yes. All right, I have a math challenge for you, and I realize I don't have the right slide up, so give me just a second. Let me grab it really quick. I do have a math challenge problem for you. I didn't give this to my other class, and I'm giving it to you. Are you ready? Okay, so here it is. Let me click on it. I will read it because it's pretty small. And here, I'll make it bigger. All right, so you are playing ping pong ball in the backyard, and you miss the ball, and it bounces across the lawn and rolls into a small but deep hole. The hole goes down too far for you to reach the ball with your hand. and it bends to one side, so you can't get the ball by poking a stick in the hole. So all you out there with sticks from the trees and the broomsticks, those are not going to work. Okay. After a few minutes, you think of an easy way to get the ball. And the key word here is easy, not complicated, easy. What did you think of? Okay, so you're thinking about that. I'm going to skim for more questions. I think I got most of them answered. Okay, you love Legos, yes. All right, I will tell you the fighter plane story, yes. Okay, can you think about two things at once? Can you think about the puzzle here and I can tell you a story at the same time and then I'll reveal the answer? Would that work? Okay, let's do that. All right, so yeah, the stories I share with you are true. One of the things I worked on as a graduate student was I actually got hired by the Air Force to help them with their research on, and this is in the 90s, so this is a long time ago. And so this is when they were first doing what they call axisymmetric thrust vectoring, which means the exhaust that comes out of the engine, they can gimbal and nozzle that thing around, and it will change the nose, where the nose of the aircraft is pointed. And now we know this, but back then it was a new idea. They would actually, the first iteration is they put paddles into the flow just to deflect the flow, and then that would cause the plane to turn. So they were really excited about this, and they put it on an F-15, and Pratt & Whitney had these new engines, and so they stuck them on there, and the test pilots were using this plane had all kinds of things going on because they were doing like multiple experiments, like 15 dozen experiments easy on this thing at once. So they decided, well, let's do another one. Let's change out the engine. So they did that. They put it on F-15, and they had these two really, really powerful engines. And they had a full thrust vectoring gimbal and nozzle around it, which they have on fightercraft these days. Okay, but back then this was the first time they'd ever done this. And so the test pilots came back and they said, well, it works pretty well, but then it doesn't work. You know, it's like we'll pull a maneuver we're expecting to do, and the airplane will just start falling, or there'll be not enough lift, or the thrust will go down like 90%, and they're like, we don't know what's going on. So so what they decided to do was to hire a bunch of graduate students like me, because we are cheap. Because in exchange for the research we did, we got to graduate, and we got to work on a project which was super cool. And we also they paid for all of the equipment, which can be very expensive if you're a graduate student. Okay, and they also paid for us. They hired us, and so we got paid and hired by the. Oh, I'm sorry. This one was for the Navy. Okay, so the Air Force was a different project. Sorry. I had a lot of projects in my in my day. Okay, so for the Navy. And so was this the one with the Navy? It doesn't matter. All right, it was for the military. How's that? Okay, let's just call it the Air Force. I'm thinking Air Force because it was an F-15, but yeah, as I said, it was an experiment. Okay, so what happened was we decided to make a mock-up of, so we didn't want the test pilots to get hurt, right, in trying to do all these questions that we had. So we made a scale model, so smaller version, and we just we had this idea that it wasn't the engine part itself, but it had to do with that deflecting the flow at the end. And so here, actually, do you want to see some photographs of it? Here, I'll be right back. Here, I'll make this nice and big so you can keep working on the problem. I actually have my master's thesis over here. I'll show you the pictures of the plane and everything. And so let me see, where is it? This is not something I share very often. Let me grab it. Oh, it's stuck in the corner. Hang on a second. I have to move something big. Note to self, make sure you know what story you're going to share so you can get your props. Okay, so here it is. All right, so this was written back in the 90s. Okay, so, all right, so here, let me get my chair scooted up. Okay, so here is my master's thesis, and let me see if I can show you the plane. So we made a scale model of it, and what we decided to do here, so this was the F-18 they had put it on initially, and then I forget which X-plane that was, and this was the one we worked on, and so it was the F-15. And so what we had done is we made a scale model. We took the engines, and so it was basically just two pipes sticking up in the air, and we had enormous pressure chambers outside the building. They were they wouldn't fit inside the building. It would have been dangerous anyway. And so we had them outside the building, and we would charge them up, and then we would blow supersonic flow. So it was going at like maybe 2,000 miles an hour. So air going 2,000 miles an hour out of these pipes. And the end of it simulated the configuration. We could put them in different configurations. So it was like a small, tiny little like a F-15 that was in, we put it on a test stand so we could measure the thrust as well and see what was going on. And here's the really cool part that I wanted to show you. So the cool part was we would angle the nozzles and we could take pictures of air flowing supersonically. And this had not been done much ever. And so being able to see air is very difficult. Being able to see it, now people can do it. There's a special technique called Schlieren photography. And we didn't develop it, but we used it very well. And it was the first time Schlieren had ever been done in video, which was really cool. So we could actually take a video of this thing firing up. So, and what was really cool is we would say, here, let me show you what happens. You know how if you pull the, like you have your faucet and you put it on just a little bit, kind of the flow kind of sticks to one side? That's what was happening here. And so because we were able to simulate this, we were like, I think this is what's happening. This is where your thrust is going. So the pilots were trying to go full power, but because of the angle, the power wasn't enough, and it was causing all kinds of problems. So what we did is we had to go through all the iterations, and we gave them performance curves that looked like this and said, okay, you can fly anywhere in this circle. If you fly outside this circle, you're angling those nozzles in a way that they won't be able to generate thrust to keep your airplane up in the sky. So there was an inequality right there, right? Okay, and so then we had, so we had lots and lots and lots of data in the back, lots of data tables, and it was a super fun project. So there you go. Yay! And so the funny part about that is, so after the project was over, I was finishing it up. We had gotten the results. They were happy. The pilots were happy. They gave us a tape of them flying this airplane upside down and backwards. And I still have it, but it's on VHS. I've been thinking I should get it because it's no longer a classified project, and I should get it and show it to you. But the plane actually goes up, 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 and it's doing a loop. And at this point, it's moving through the air, and it's actually flying backwards. Because they stayed in our performance envelopes. And sure enough, the engines were strong enough to pull enough stuff and shoot it out the back. So I'm late in there. You guys want the second half of the story? I think I've told this only like twice. So I'm in the lab late at night, and I'm not doing, we're not doing them much, right? And so I'm one of the very few people that can get in there because they have lots of other engine labs in there. They have like the glass engine going. They have the hybrid rocket, the see-through rocket. And they have a lot of stuff you don't want people messing with, right? So I'm in there, and I'm like, so I see, and I've got my rocket dynamics book open, and I'm like, hey, the book says assume this. And I'm like, I wonder if that's true. And I'm like, I've got a test stand right here. I'm like, these things are similar to rocket engines. And so just in like 10 minutes, I outfitted the thing, and I had the photography, the Schlieren videography going. And so I was testing something. And wouldn't you know it, the minute you shouldn't really be doing something, like I wasn't, it's not that I wasn't supposed to be there, I just, okay, you get it. All right, so I hear footsteps, right? As soon as it blows up and it makes the loudest noise, you have to wear hearing protection because it's super loud. And then as soon as the loudness comes down, I take this off and I hear click, 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 click. I'm like, oh no, and I turn around and it's my advisor. And the professor in charge of he's the PI, the principal investigator. He's the one in charge of the project, right? And it's not just him. It is like the head of the program that is working on this, along with one of the main managers for Skunkworks, right? So which is also in that day was working with like Lockheed and yes. So anyway, so I turn around and I'm like, "Hi, Professor Carpenter," and he looks at me and he goes, "What are you doing?" It was just like this, what now? Like, oh, and he was feeling very embarrassed. And so, and then I was too. And I'm like, I'm trying to position my body in front of the monitors, like, nothing going on here, nothing at all, no. And so it turns out that the Skunkworks guy, he looks and he goes, "Oh, that's really interesting." And he's trying to get around me, right? And I'm like, well, busted, right? Okay, sorry. I'm like, I can explain. And he goes, no. I don't think you need to. And he looks at the experiment and he looks at what I'm doing. And it took him all of about 10 seconds. And he's like, "You're testing this theory, aren't you?" And I was like, and it wasn't a theory. It was it was a proven fact. But like, so I was like, yeah, actually, I wanted to know, like, is it true? Is it not true? And he's like, he looked at me and he goes, how do you feel about Palmdale? And I said, what do you mean? And he goes, I'm offering you a job right now. I'm like, but I haven't graduated. And he goes, I need your mind working for me. So if you know anything about these types of positions, so it turned out it would have been in a building. My job was going to be underground, super classified, no windows. And if I had taken it, I would not be sitting here talking to you. So you never know. You never know. So what went on there? So my takeaways was I'm curious about the world. I'm excited. I have the tools that I need to get that out there and explore it. And I'm not afraid to try things, not recklessly, not carelessly. I'm not playing, soccer on the freeway, right? But I'm curious about the world, and I want to know things for myself. And I wasn't applying for a job. I wasn't even trying to be, in front of everybody saying, look how great I am. But what I got from that was there are certain things that really make good engineers. And that's what I'm passing along to you in these math classes and my science classes, because these are the things that really make you stand out to people. Because people notice this and they're like, you saw something nobody else did. You did something nobody else did. And how you get to that point is by being curious, asking questions, and just trying things. And knowing that most of the time you're gonna fall flat on your face and it's not gonna work. Tons of experiments I didn't work. I made a mistake in class today. I think somebody corrected me, right, with the minus and the plus sign. I make mistakes all the time. And so that's okay. Making mistakes is part of the process. And you got to be okay with screwing up royally and just being able to pick yourself up, dust yourself off, and say, what's next, right? What's next? So yeah, so I did not take that position. That was not one I was interested in. I did take another position, which I will tell you about at another time. Yay! All right, you tell me, did you type in your answer to the puzzle? Did you type in your answer? You better, because the solution is coming to you. Are you ready? All right, so the puzzle, remember, you dropped a ball. It's a ping pong ball. This wouldn't work with other kinds of balls. If you dropped a ball bearing, it wouldn't have worked. My solution. You may have thought of a solution. I didn't, and that's totally okay. So what did you figure out? Okay, the ball. All right, so you could use a vacuum cleaner. Oh, your mom would probably not appreciate it if you jammed her vacuum cleaner with dirt. Remember I said not complicated. Yeah, okay, that's a solution. That's a solution. Okay, dig it out. I'm kind of lazy. I don't want to do that much work. And it's a really deep hole. Yeah. Ooh, Ivory is the one who got it. Ivory, did you come up with that on your own? All right, can I read Ivory's solution? All right. What happens if you fill the hole with water? What happens to the ping pong ball? Yeah, it bobs up to the surface. Yeah. Yay! Was that an easy solution? Yes. Does your lawn like the water? Yes. Did you rip a hole in the backyard and your mom's mad at you now? No. Did you clog up her vacuum cleaner? No. As I said, you could have had a different solution. I would have filled the thing up with water. Are there more than one solution? Of course. But I wanted to see what you came up with. Get another ball. Okay, that's one solution for sure. Okay. Good. Yay. All right. Did you guys have fun? Okay, I'm going to put the recording up. If you have questions, you're going to let me know. Your job now is to start working on your workbook. You're going to download the math assignments session for session 3. Remember, there's 40 to 50 videos on this page for session number 3. Take your time. You're not doing them all. You're doing as many as where you are right now. So if you're working on something and you're like, too easy, skip it. I want you to do something else. If you're working on something, you're like, I am lost. Okay, back up a little bit. Okay, so beginner stuff, we're introducing the concept. Intermediate, you know the concept and we're practicing. So if you're trying some of the intermediate and you're like, I'm lost, go back to beginner. And then you may only need 10 or 20 minutes in the beginner section. And you're like, oh, I got it now. And then go back to the intermediate section. Okay, and then do as much of that as you can, because in the next week, we're going to be talking about a whole nother area. Somebody's asking about Doug's class. It's on Thursday, and so he is going to be not introducing anything new. He's going to talk about inequalities, absolute value, and then he's going to take it from there. Yeah, we just briefly talked about functions because next week we're going to talk about them a lot. So I just briefly introduced them. Okay, good. All right, any other questions? You're welcome. I'm so glad you enjoyed class. All right. If you have questions, let me know. We're at superchargedscience.com. I will see you next time. Bye-bye, everybody.